Let's solve LeetCode 200, number of islands. This is actually one of my favorite problems because I feel like a lot of graph problems build upon this one, and you can learn a lot from just this one problem. It's also a really popular interview question. A lot of big tech companies, including Google and Uber, ask it, so it's a good question, a common question
Step into Wix Studio, the platform for agencies and enterprises, and turn website layouts into
to understand. So we're given a 2D grid where ones represent land, zeros represent water. We want to count the total number of islands that exist, right? And in this case, an island is defined as ones being connected adjacently horizontally or vertically, not diagonally, right? So they have to be connected horizontally or vertically. And the entire grid is surrounded by water. So in this example case, we can see that there's only one island, right? This portion of ones, and they're all connected horizontally and vertically, and there's nothing else. The rest of the grid is just made up of water, so we don't have to look at it. So if you don't know how to solve the problem, the first thing you should do is not try to write any code. Just look at the picture and try to get as much information as you can. So think about it. How would a kid solve this problem if you gave them the picture and told them to count the number of islands? Well, the first thing you would do is notice, okay, let's start at the top left. Hey, there's a 1 here, right? Okay, that means it's an island. How many other ones are connected to this one horizontally and vertically? Just by looking at it, right, you kind of draw the outline. There's all these ones that are connected to each other. So then that's one island. We can say that the number of islands we have so far is 1, right? And if you look at the other ones, right, maybe we have to count those as well, like this one. But you notice it's already a part of the island that we drew, right? This outline, it's already there. We're not going to count it twice. These ones are a part of the same island. So the count of islands remains 1. And after looking at each of these ones, we'd conclude the same thing, right? They're all a part of the same island. Next, we could look at some of these zeros, right? Okay. Okay, we check, is this an island? Nope, it's water. So just cross it out, right? Don't need to consider it anymore. Is this an island? Nope, it's water. This is water, 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 this is water. It's getting pretty repetitive, but this is water, still water, this is still water. But now we get to a 1. That means we found another island. And it's not a part of this island that we already counted, right? It's a part of a new island. So we're going to update the number of islands, cross 1 out. Now we're going to put 2. But we have to remember that we have to count all the ones that are connected to this one. And there's only one right neighbor that it has, right? And so the total number of islands is now 2. When we get to this one again, we see it's already a part of the island that we already counted, right? So we don't have to count it again. So we visited every single cell and we concluded that the total number of islands is 2. So now we kind of have an idea of how the algorithm works, but the difficult part is that you might not know unless you know a little bit about graph algorithms, is how do we actually determine this entire area, right? How do we get all of the adjacent neighbors of an island? How do we mark them as visited, right? Let's take a look at how we can do that. So when we first got to this one, we realized we got to an island, but then we wanted to mark the contiguous land of this island as visited, right? So the first thing we could do is say, okay, well, the adjacent neighbors of this one also have to be marked visited. So its neighbors are this one below it and this one to the right of it. Okay, but we're not done yet, right? There could be even more ones connected to these two that we just visited. And then we can say that for this one below the first one, its neighbors are this one and this one. But what about this one above it? Well, it's already visited, so we don't want to mark it twice, so we're not going to do that. Now let's get the neighbors of this one that was to the right of the original one. So it has one neighbor to the right of it. It also has a neighbor below it. But hey, we already marked that visited, so we don't need to do that again. And then let's look at this one and see its neighbors. Well, it only has one. And then we notice that this one doesn't have any neighbors that aren't already visited, and this one doesn't have any neighbors that aren't already visited either. So you might already know what this algorithm is, but it's basically a breadth first search. We're just doing a graph traversal algorithm starting at the original point over here and marking each layer of ones. So in the first layer we got this, the second layer we got this, the third layer we got this, and the fourth layer we had just a single value. So this is really easy to visualize, and if you already know this algorithm, you can code it up pretty quickly. So knowing what we just learned, let's code it up. So the first thing, just do some input validation. If we had an empty grid, we don't want to have to run our algorithm, and we can simply just return 0. There aren't any islands in that case. The next thing I like to do is just get the dimensions of the grid, so the number of rows and the number of columns. We can get the number of rows by doing this, and the number of columns by doing this. We also want to be able to mark positions or cells visited when we're marking island masses, so I'm going to use a set to do that. We could also use a 2D grid if we wanted to, but I think sets are a little easier. We also want to count the number of islands. We can initialize that as 0. So we want to visit every single position in the grid. So let's iterate through each row and column. So R is going to go through every single row. C is going to go through every single column. If we visit a 0, we don't have to do anything, right? But if we visit a 1, then we have to do something. Then we have to traverse it and mark it visited. And don't forget that this 2D grid is actually made up of strings, not numbers. That always trips me up. I think it's kind of annoying that LeetCode does that, but it does. So now we have to run our traversal. I'm going to run breadth first search because I kind of like it. So run breadth first search on this cell, row, column. We also have to increment the number of islands. But remember, we're only going to be incrementing the number of islands if we get to a one that we haven't already visited. So we're going to make sure that if we execute this, we've gotten to a position we haven't visited. And then ultimately, we're just going to return the number of islands. But we didn't actually write our breadth first search. Let's do that right now. So breadth first search is not a recursive algorithm, it's iterative. So we need a data structure to use for memory. So a queue is normally used for breadth first search. So we want to mark this position visited as well. So to visit, we're going to add this cell that we're about to use our traversal on, RC. We're also going to add it to our queue. And so while our queue is not empty, that means we're going to be expanding our island. So we're going to pop from the queue. And we want to check the adjacent positions of this position that we just popped. So the way I like to do that is use a loop. So we know that there's 4 directions that we can go in. The direction to the right, which is 1, 0. The direction to the left, which is -1, 0. The direction above, 0, 1. And the direction below. Now, for each of these directions, we're going to check something. First, we want to check that this position is in bounds. The way in Python I like to check that is just if r plus dr is in range of rows, and check that the column plus direction that we're moving in is also in range of columns, and that this position is a land position. So this is equal to 1, meaning it's land. And lastly, that this position hasn't already been visited. So if this is true, then we can add that to our queue because that means we have to run breadth first search on this cell as well. We also have to mark it visited so we don't visit it twice. I noticed that we're doing this computation a lot by adding row plus direction of row, so I'm going to fix that really quickly. So that's a little bit cleaner, and that's pretty much the entire breadth first search function. It's going to be running until the queue is empty, which means that there's no more land positions to visit. I had a sloppy bug. I forgot to add this row column position as a tuple, which we want to do as a pair, not two elements separately. I also used the wrong function name for visit. We have to use visit add, not append, because it's a set, not a list. And there is the breadth first search solution to this problem. Sorry about a few of the bugs that I let's So that's a little bit cleaner, and that's pretty much the entire breadth first search function. It's going to be